Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Zairul Shafira Idayu binti Muhammad Saufi with metric number 1170884. Alhamdulillah, today I will present about my research proposal on title Synthesis of Hematite Nanoparticles by the Sol Gel method in polyol medium. So first thing first, let's see about the background of studies. Nanoparticles are known as material with length of 1 to 1000 nanometer scale. Nowadays, research on nanoparticles are growing so fast due to their physiochemical characteristic like melting point, electrical and thermal conduction, and catalytic activity compared to their bulk counterpart. So, nanoparticle can be classified into three categories, which is incidental, engineered, and naturally produced. It also can be classified into four material-based categories, which is carbon-based, inorganic-based, organic-based, and composite-based. So, different material-based and different origin will lead to the different morphology and the size of nanoparticle itself. So, let's talk about hematite nanoparticle. Hematite nanoparticle is one of the example of engineered and naturally produced nanoparticle. Naturally produced hematite are widely found in rocks and soil, while engineered hematite usually produced via chemical method of synthesizing nanoparticle, such as Sol Gel method, co-precipitation method, forced hydrolysis, and pyrolysis method. So, method of synthesizing nanoparticle will influence and affect the morphology and the size of nanostructure. Based on my research and reading, method, the origin, and the material base is not the only factor that will affect the morphology and the size. Besides, organic and inorganic additive, solution pH, solvent, nucleation rate, iron ferrum 3 plus concentration, reaction times, types of ferrum, iron ferrum 3 plus salt, and aging time are strongly influence the morphological and the size of alpha ferrum oxide nanoparticle. So this is the example of same image of shaped iron oxide with 6 different morphology. The formation of this nanoparticles of iron oxide is influenced by the method, the types of solvent, nucleation rate, the reaction time, the temperature, and the other factor that I told before. So actually, hematite is one of the phase of iron oxide as it exists in a different phase, such as alpha ferrum oxide, which is hematite, beta ferrum oxide, which is magnetite, gamma ferrum oxide, which is maghamite. So based on my reading, hematite is the most attractive and significant metal oxide, as hematite show a magnetic properties that beneficial to a magnetic material like photocatalyst, medical application in oncology, in sensor, which is to detect the hydrocarbon and carbon dioxide gas, magnetic resonance imaging, and targeted drug delivery. However, magnetic properties of hematite is depend on the morphological and the crystal structure of the starting material. So, further research of hematite nanoparticle is very essential to enhance its properties by achieving better control of particle size, crystallinity, and magnetic properties. So, let's move to the problem statement. There are several methods of synthesizing nanoparticle, such as physical, chemical, and biological method. Some methods are toxic, chemically hazardous, costly, energy-consuming, and complex separation techniques. So I give a few examples, such as physical method. It's require expensive and highly complex machine, while biological method is very slow and very laborious. And such a chemical method, such a hydrothermal, it require high pressure and high reaction temperature, which is so much energy consuming. So these researchers will use chemical method, which is sol gel, due to the cheap, simple, and environmental friendly. Besides, sol gel is precisely controlled in size and internal structure that can enhance nanoparticles properties. So there are three objectives of this research, which is first, to synthesis hematite nanoparticle, which is alpha ferrum oxide nanoparticle, by the sol gel method using different types of polyol, vary the temperature of the calcination of the resultant alpha ferrum oxide nanoparticle. And the last is to elucidate the effect of the studied parameter on the physical properties of the prepared alpha ferrum oxide nanoparticles through several analyses. So, the scope of the study will begin by the synthesizing alpha ferrum oxide nanoparticle through the sol gel method using three polyol, which is the solvent, ethylene glycol, 1,3-propanediol, and glycerol. The iron salt to polyol will be varied in the synthesis, weight over percent volume, which is 50, 100, 120, and 115. The resultant nanoparticle will be calcined at three different temperature, which is 300, 500, and 7 degrees Celsius. The obtained alpha ferrum oxide will be subjected to the following analysis, which is SRD, SEM, and EDS, and particle size analyzer. So let's see about the methodology of synthesizing of hematite nanoparticle. Okay, the first step is ferrous nitrate nanohydrate will be mixed with polyol, which is the solvent. Then the solution will be stirred at room temperature until the formation of the sol. The third step is the sol will be heat at 80 degrees Celsius to obtain the gel. Then the brown zero gel will be crushed using mortar and pestle at room temperature. Then it will be annealed in a furnace at very high temperature to obtain alpha ferrum oxide, forming a fine powder. So the procedure will be repeated for the other ratio salt to polyol. So the obtained hematite nanoparticle will be characterized using three instruments, which is SRD, SEM, and EDS, and particle size analyzer. SRD will measure the peak of nanoparticle obtained, either it pure or mixed with other material. The SEM will show the surface topography and the composition analysis of hematite nanoparticle. SEM will show the morphology of the nanoparticle obtained, while particle size analyzer will analyze the particle size of nanoparticle obtained. So let's see about expected result. In my research, I just expect two results, that the ratio of iron salt to each polyol is expected to affect the size and the morphology of hematite nanoparticle. The ratio cannot be too small or too high, as too small ratio will cause failure in forming hematite at nanoscale dimension, while high ratio of iron salt to polyol will give problem, which is difficult for us to control the uniform size of hematite nanoparticle. The second is increasing in calcination temperature is expected to produce stable hematite nanoparticle. At 50 degrees Celsius, is expected to form stable alpha ferrum oxide due to the complex thermal transformation. Due to the complete thermal transformation at 15 degree Celsius. So that's all from me. Assalamualaikum warahmatullahi wabarakatuh.